Okay, part 2, number 11. Let's get her going. Convert the following 4 pi over 3 radians to degrees. Well, different ways to do this, but pi over 3, remember pi over 3 is just the same thing as 60 degrees, so this should be an easy one. This is just 4 times 60, which is 240 degrees. Then this, 4.5 radians. See, there's no easy way of using your automatics, so we have to use our formula. 4.5 radians over 1, we're going to multiply that by 180 degrees over pi radians. This is going to be a calculator special here. So, we see that the radians cancel, and that's our whole goal, because we only want degrees. So now we just have to use our calculator, 4.5 times 180, and divided by pi. And we get 257.8 degrees. All right, and remember, 1 radian is a little less than 60 degrees, but 60 times 4 is 240, and then another half would be 270. We're close, so we feel good about that. All right, let's go on to this next one here. Okay, so 225 degrees, we got to convert that to radians. If you think about it for a second, yeah, you could use your formula, but 45 degrees times, give me a second, just wanted to double check before I made a silly mistake. 45 times 5, you can see on my calculator, is 225. How are we going to use this? Well, we know that 45 degrees in radians is pi over 4. So we just multiply that by 5. So we would get 5 pi over 4. Remember, pi over 4 is 45, so there we've done it. 5 pi over 4 radians. This one, next one's not so easy. So we have 231.1 degrees, there goes my pencil again, degrees over 1. We're going to multiply that by 180 degrees underneath pi radians. Remember, this equals 1, so we're not changing its value, we're just changing the way it looks. So the degrees cancels, leaving us with only radians, so that's good. And so now we're going to get our calculator out. 231.1 times, I'm just going to go 3.14 this time, and I'm going to divide that by 180, and we get 4.03 radians. Now some of you might panic, like, well, how far do you want to round this? Well, don't worry about that. It's going to be multiple choice in this situation, so you're going to look for the closest thing. There you go. So here we go. Number 12. Find the smallest angle. Well, I've already got the triangle drawn, the 7, 24, 25 right triangle, so we know that's a 90-degree angle, and that allows us to use SOHCAHTOA if we have a 90-degree angle. Well, the smallest angle is going to be here because that's opposite the smallest side. So here's my reference angle. I'm going to use tangent. You could use any one of these, but I'm going to use tangent. So I'm going to go tangent of theta. Remember, tangent is opposite over adjacent. We know this is the hypotenuse. And now we've got to just go inverse sine, because that's the way we tell our calculator to find the angle for us. So second tangent, I said sine, I meant tangent. Inverse tangent, 7 divided by 24, and there it is, 16.26. 16.26 degrees. Oh, and another thing to think about is make sure your calculator is in degree mode before you do all this. Go to your mode. You can see that my degrees highlighted, and make sure you take care of that during an exam especially. Number 13 says solve for h. Now, you can tell there's 2 variables, so this really means isolate h. A lot of you, when we took the Unit 1 test, you thought you had to find h, like h is 12 or 12.9. That's not what we're doing here. We're just algebraically isolating the variable h and then calling her good. So, We can't just cancel these. That'd be silly because we're trying to solve for h. You can't do it mathematically anyways, but we're going to multiply this side by 5h plus 2. So those cancel. But then we got to do the same thing over here. So I'm going to distribute that x through here. So I'm going to get 5hx plus 2x equals what's left over here, and that's 5h minus 2. Now remember, we're trying to isolate h. So what I'm going to do is I'm going to bring this over, and I'm going to get rid of that 2x over there. Now be careful, these are not like terms. So I'm going to go 5hx minus 5h, these cancel, equals, these cancel, these are not like terms, so negative 2 minus 2x. Now if we're trying to isolate h, solve for h, we can factor in h out. We're left with 5x minus h equals negative 2 minus 2x. And we're just going to divide by that mess. So it cancels, but then we got to do the same thing over here. Whoops. Hold on a second. Some of you probably noticed I made a mistake. If you factor an h out of this, you're not left with an h, you're left with a 5. Sorry about the mess, you guys. And there's a 5 there. And then so there should be a 5 there. So my final answer is h equals negative 2 minus 2x all over 5x minus 5. Now, in the great world of math, you have to be careful putting that down as your answer without thinking, is this simplified? Because you can see I can take a negative 2 out of there. So I'd be left with 1 plus x. And I can take a 5 out of here, 5. And I have x minus 1. Now these are very close to being able to cancel, but you can't. So this is a good answer. It's probably the best answer, but this would also be considered an answer as well, because you can't simplify it even if you tried, but you should at least try, because you never know. This could have reduced to negative 2/5 quite easily, but it didn't. So there's number 13. All right, next problem. What's tangent of negative 3 pi over 4? Well, the first thing we got to realize is this is a spinner problem. Then we got to realize, and you always start here, you always, then pi over 4 is 45, so negative 3 times 45 degrees is negative 135 degrees. Negative means down. So there I've gone 90, and I got to go another 45, which lands us right here. Now if we drew our triangle, we think, wait a minute, this doesn't have sides, but this is a 45, 45, 90. Remember, our sides are 1, 1, square root of 2. This is my reference angle, making this my opposite, this is my adjacent, and that square root of 2 is my hypotenuse. But we got to remember, this is a negative and that's a negative. So with that being said, tangent of this situation would be opposite, negative 1 over negative 1, which is just 1. Number 15. Solve. Well, we got our trinomial here, so we got to set it equal to 0. So x squared minus 32 equals 4x. The first thing I'm going to do is subtract 4x, make it look like a trinomial. We cross our fingers, and we hope this thing's factorable, because it's always the easiest. And lo and behold, this is factorable, because two factors of negative 32 that add up to negative 4 are negative 8 and 4. So my two answers would be 8 from here, or negative 4 from here. There's my two answers. Next problem, very similar. The first thing I would do is I would notice, because this is an equation, everything's divisible by 2. It's better to use small numbers than big numbers. And so we get 2y squared plus 11y plus 5. Now, is this factorable? The answer is yes. I believe it is, but I think most of you would probably use the quadratic formula. So here's my a, here's my b, here's my c. So I'm going to use the formula negative b, so the opposite of that, negative 11 plus or minus the square root of b squared, which is 121, I just squared that, minus 4 times a times c, all over 2a, which is 4. So let's condense this a little bit. So I get negative 11 plus or minus. Now this is 20, 40. So 121 minus 40 is actually 71 all over 4. Let me double check that. All right, I'm glad I double checked it. It's 81. I'm under pressure when I'm getting this recorded. It's 81, which is a big difference because look at it, the square root of 81 is 9. So I get negative 11 plus or minus 9 all over 4. That is not your answer yet. So negative 11 plus 9 over 4 we have to investigate, and a negative 11 minus 9 over 4 we have to investigate. Well, this is negative 2 over 4, which is negative 1/2. This is negative 20 over 4, which is negative 5. Now, when you get a perfect square root like that, that's telling you that this is factorable. So we could have spent some time factoring that, but we didn't. All right. Okay, number 16. For the parent function y equals x cubed, use your language of transformations to describe the changes to, and there's the changes, and then sketch the graph. So, here's the deal. We got to know what this looks like. This is one of our parent functions, and by now we should know that 0, 0, 1, 1, 2, 8, and so it comes in like this, and if you throw in negatives, negative 1 would be negative 1, negative 2 would be negative 8, and you can see that it looks like that still. That was a little sarcasm right there. All right, so what happens? Well, as we can see, this thing's going to flip over the x-axis, and I'm going to go one step at a time. So this portion flips up like this, and then this goes down like that. So there, we took care of step number 1, dotted because we're not anywhere near being done. The 2 means there's going to be a vertical stretch by a factor of 2. What does that mean? And I'm just going to continue changing colors here. It means it's going to go up faster, which means it's a little bit skinnier. So there we go. We're up to that dotted pink line. But now we got to move that we got to move it to the left 2. So we got to take that last skinny pink dotted line and move it left 2. I'm going to do my best. That's why it says sketch. So we're going to move it left 2, 1, 2, and do our best to kind of duplicate it. There, not bad. But then the final moment, we're going to use orange. So we'll just say we're done with the orange. Is we got to move that whole thing down 2. So this is my locator point. So I'm going to go down 2 from there. And again, try your best to just duplicate what you had. Is it perfect? No. Does that get the job done? Yes. So that's my answer. On your final exam, it'd be great if you label that. Okay? All right. And some of these are going to be not multiple choice, and that demonstrates why. All right, number 17. If h of x equals this stuff and f of x equals this stuff, remember Phil Collins' song Inside Out. So this turns into h of whatever f of x is, so x minus 1, which means this needs to plug into the equation defined by h, which is right here. So we got to go 3 times x minus 1 squared minus 1. So now it's just basically an algebra problem. Remember, you can't just square this and think you're on the right path. We actually have to FOIL it out. So we get x squared. I'm going to go outside, inside, minus 2x plus 1. Now that's times 3, that 3 right there. So I'm going to distribute it through. 3x squared minus 6x plus 3, but don't forget about that little bugger, minus 1. So 3x squared minus 6x plus 2. There's my final answer for that problem. Okay, number 18, breaking down a fourth root problem. So the first thing we're going to do is look at the fact that 2 times 2 times 2 times 2, that is 2 times 2 is 4, times 2 is 8, times 2 is 16. So this breaks down to the fourth root of 16 times the fourth root of 2. Now, the same rule applies here, but it's a 4 in the index. So what's the first number less? Now, this is number land. Now we're going into letter land. What's the first number less than 11 that 4 goes into evenly? And that would be y to the 8th, leaving us with 3. Here's my perfect fourth root, perfect fourth root. So the fourth root of 16 is 2. 8 divided by 4 is y squared, and then these two just kind of join. So times the fourth root of 2y cubed. A lot of algebra in good old Pre-Calc A. So I'm trying to keep these in 15-minute chunks, and that finishes the second part. All right.